Welcome. On this video, we're going to be discussing combination and permutation. So let's get started. Let's start by looking at the small introduction question, which states, at a swimming competition, 7 swimmers compete in a race, and the question is, how many ways can they place first, second, and third? So what exactly do we mean in this example? Well, let's draw our 7 swimmers. So let's assume that each of this dot represents one swimmer, so we got 7 in total. And we want to select them in such a way that we want to create groups of first, second, and thirds. So there's one possible selection that we can do, and that is, well, let's say that the first got first place, second place, and the third swimmer got third place. This is one possible selection that fits these characteristics. There are 7 swimmers, and we have selected a first and a second and a third place. This is one possible. Well, there's another possible selection that we could have gotten. Well, let's say that the first place didn't even make it on the first 3, and now the fourth swimmer was the one who got first place. So this is another possible selection. The fourth swimmer got first, the second and the third, they still on their same place. There's another possible combination, or I should call it combination. It's a possible selection. Now let's assume that now the seventh swimmer is the one who got first place. This is another possible selection. Another possible selection, it could have been, well, what if now the fifth swimmer got second place? And notice that there are just so many combinations. There are so many selections that we can get from this example. So now the question becomes, how many selections can we create in total? Well, one way that we can tackle this problem is by looking at the following. Well, we know that there are 3 possible places that we're looking at. This is for first place, this is for second place, and this is for third place. Now, how many do we have in total? Well, we have 7 swimmers in total. So therefore, I can say that there are 7 possible combinations that I can place for the first place. Now let's think about this for a second. How many possible combinations or selections can I get for second place? Well, since one of them have already been selected as the first place, now there are 6 swimmers that are left to select from. So I'm going to say, well, if I already selected one for 7th place, then now there are going to be just 6 possible selections for the second place. Now, for the third place, there are 7 in total. There was one person who was already selected for first place. There was another person selected that's already on second place. So now there must be 5 to select from that we can place it on the third place. So therefore, the total ways or the total selections that we can get is by multiplying them. So 7 times 6 times 5, which is equivalent to 210 ways. So therefore, if we were to come up to the illustration here, there are 210 different ways that we can create selections that will still meet this criteria. And now this is going to lead us to what a combination and what a permutation is. So there's a slight difference between a combination and a permutation. And let's just show what that difference is. Well, the way that we're going to be defining a combination is that a combination, it is ways of selecting objects. So it is ways of selecting objects from a group of objects or collection where the order does not matter. This is very important. Under combination, the order does not matter. In a permutation, it is still the same procedure. This is a way to describe selection of objects from a group of objects or a collection where the order does matter. So under combination, the order does not matter. And under permutation, the order matters. So if we go back to the example that we had as an introduction, notice that this is essentially what we were doing. Now it says a combination or permutation, it is still defined as selecting objects from a group of objects. And that's what we did here. We have a total of 7 swimmers, and we selected 3 of them. What we have done here is we selected objects from a group of objects. The group of objects was 7 swimmers, and we selected just 3 of them. Now the question is, did the order matter? Did the order matter on how we were selecting those individuals? Well, if the order does matter, then we would call that a permutation. And if the order of how we're selecting those individuals does not matter, then we're going to call that a combination. Now, if we come back to the problem that we stated under the introduction question, notice that the way that we selected those individuals, it did matter. Because if we already selected one person for the first place, then we just cannot select that same person for the second place anymore. So notice that this example that we were doing under the introduction, it is an example of a permutation because the way that we were selecting those individuals from the group of swimmers, it did matter. Now, how can we properly find out the total amount of objects or groups that we can create from those objects are? Well, it just so happens that we do have a formula to properly define the numbers of groups that we can create under a combination and a permutation. And this is how we find them. Well, given n distinct objects, the numbers of ways to select our objects where the order matters. Sorry, this is a combination, so the order does not matter. The way that we compute combinations, it's by the formula n factorial over r factorial times n minus r factorial. Now, there are some notations that we do have to illustrate here. Some notations that we can use is n big R, big C little r. Now, this is the notation that we can indicate of combination. This is saying there are n objects in total, and I want to take a combination of this many. So n combination of r, this is how we can compute it. And remember what factorial means. Remember that under factorial is just a small notation that we use to indicate multiplication. So let's assume 4 factorial, that's equals to 4 times 3 times 2 times 1. 7 factorial, it's 7 times 6 times 5 times 4 times 3 times 2 times 1. So we're using the idea of factorial to define combinations and also permutation. Because under permutation, where under permutation the order does matter, the formula we'll be using is n factorial all over n minus r factorial. Where I guess one thing that I'm just not indicating too well is that n is the total amount of individuals that you do have on the group, which in this case, if we go back to the example that we did as swimmers, then in this case, n, it will be 7 because there are 7 possible selections that we can choose from. And r is pretty much the size of the group that you want to create. Where if we go back to the example that we had as on the swimming, in this case, n, it will be equivalent to 7 since there were 7 swimmers, and r, it will be equivalent to 3 because we wanted to create groups of 3. And why is it that there were groups of 3? Because you need 3 possible selections to fit the characteristics that we were given in this problem. So this is just some formulas that we'll be using. Now, one thing that I have to state again is just the notation that we'll be using here. Because again, another way that we could use for permutation, well, we can use it as n, little n, big P, and then r. This is the notation that we can use to illustrate permutation. Now, I want to make it clear that this is not the only notation that you might be encountering in some books. Because combination, and let's just say it here, another notation, we could represent a combination still as C parenthesis n comma r. This is just another way that we can just still represent the idea of combination. Another way that we can also represent it is by just opening up a parenthesis and put an n on the top and an r on the bottom. This is just notation. Like they still mean the same. C parenthesis n r, it's still equivalent to this equation. And a big parenthesis with an n on top and r on the bottom, they're still talking about the same formula. It's just that we could express the same formula in 3 different ways. Little n, big C, little r, or we can just say C parenthesis and r, or we could just say n parenthesis r. Coming back to permutation, another notation, so one notation is n big P r. Another notation that you might encounter is just a big P and a parenthesis and an r. So there are just 2 notations that we can use for permutation. So now let's actually go back to the problem that we had here as an introduction. And now we have already stated that the problem on the introduction, it is an example of a permutation. So let's try to use this formula and try to see if we actually get 210 as well. But we can write down the formula or we can just use our graphing calculator. So how can we find permutation and combination using our graphing calculator? Well, since we know that this is a permutation, we're going to be looking at the button of math, and then we're going to go to probability. And notice that option 2 will give you an option of permutation. But the way that we're going to be using this option is the following. We're not just going to be pressing 2 right away. What we have to do is first define the value of n, which in this case is 7. And then we're going to hit math. Go to probability, go to option 2. And I notice that you say 7p, and then on the right-hand side, we're going to be putting down the value of r, which in this case is 3. And notice that we're still going to get the value of 210. Or if we want to do this manually, because that's with the calculator. But if you want to actually use the formula, um, so let's just try to do this real quick. So remember that for permutation, so NPR, that's equivalent to n factorial all over n minus r factorial. Well, n is 7, so we're going to get 7 factorial divided by 7 minus 3 factorial, which is equivalent to 7 factorial all over 4 factorial. But remember that 7 factorial, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's equivalent to just 4 factorial. So we're going to divide it by 4 factorial. 4 factorials are going to cancel out. And now the numerator is nothing more than 7 times 6 times 5, which is still 210. And notice that we still get the same result regardless, but obviously the calculator can do it faster than us. So we're going to be using the calculator to properly come up with the combination and permutation throughout these examples. So let's just, now that we have explained what is the idea of a combination, what is the idea of a permutation, what's the difference between them two, and now we have an actual formula that we can use to define the combination and permutation. And also, we have used a calculator. So let's just do 2 more examples. So let me just highlight here the formulas for each one of those. Let's take a look at 2 examples now. State, and at least the direction it says, state if each scenario involves a permutation or combination. Let's find the number of possibilities. Well, under example A, it states, well, there's a Castle. Well, Castle and Joe, Castle is a person. Castle and Joe are planning trips to 3 countries this year. There are 7 countries and they would like to visit. Now, one trip will be 1 week long, another 2 days, and another 3 weeks. Well, regardless if it's a combination or a permutation, we have to define what's the value of n and what's the value of r. So it states that they are planning a trip to 3 countries, and there are 7 countries that they would like to visit. So the total amount of countries are 7, and they want to choose 3 of those 7. So therefore, n is 7 and r is 3. Now we want to decide, does the order matter? Well, it says one trip will be 1 week long, another 2 days, and another 3 weeks. Well, in this case, the order does matter, because if you already visit one country, then you cannot just visit it one more time, well, like an extra time, because you want to visit 3 different countries in total. So in this case, the order does matter. And since the order does matter, then we know that we have a permutation. There's no end, permutation. So now that we know what the value of n is, now that we know what the value of r is, and now we have said that it's a permutation, so let's just remember what's the formula for permutation. So NPR, that's equivalent to n factorial divided by n minus r factorial. So let's actually do this example. In this case, n is 7, so 7 p3, it's equivalent to 7 factorial divided by 7 minus 3 factorial. The way that we're going to compute this is just by using a graphing calculator. So let's get a graphing calculator. Let's plug in 7, because 7 it's n. So we're going to do 7 math. We're going to go to probability, and we're going to hit permutation. And we don't press enter right away. We want to put down the 3 on the right hand side. So 3. So that gives me a total of 210 ways. Which is almost the same idea as the swimmers ones. Now let's take a look at B. Under B, it says there are 110 people at a meeting. They each shake hands with everyone. How many handshakes were there? Well, the first thing that we want to do is, again, define what is N and define what is R. So there are 110 people at a meeting. So therefore, my value of N, it's 110. Now, what's the value of R? It states they each shake hands with everyone else. So in order for people to shake hands, there must be two hands touching each other or shaking each other. So therefore, you want to create two groups of two, because each group of two, you can think about it as one handshake. It requires two individuals to have a handshake, so therefore my value of R is of 2. Another way to interpret this question is you have a group of 110 and you just want to say, well, how many groups of 2 can I create from this? Well, now that we have that out of the way, we want to answer this question. Well, does the order matter? Well, notice that here it doesn't have any restrictions on the problem. It doesn't say that if you shake the hand with one person, you cannot shake it again. It just says that there are 110 people and they are going to be shaking hands. How many handshakes were they? There is no restriction with how we want to be shaking those hands. So in that case, in the order does not matter. Well, since the order does not matter, then this is a example of a combination. So now that we know that it's a combination and we know the value of n and r, well, let's just refresh what's the formula we can use for combination. Remember that combination, it was defined as n factorial divided by r factorial times n minus r factorial. So let's just actually compute this. So now we're going to have 110 combination of 2's, and we're going to get 110 factorial all over 2 factorial 110 minus 2 factorial. And we're not just going to compute it manually. Let's actually just let the calculator do the work for us. So now we're going to be pressing 110, mathematics. We're going to go to probability. And we're going to go to option 3, which goes option 3 now talks about combination. I'm going to press enter. And now we don't press enter right away. We got to put a 2 on the right hand side. And now that we have that, we have a total of 5,995 handshakes that we could have gotten. And now with this, it concludes our lesson for combination and permutation.